Let's talk about unit tangent vectors. Unit tangent vectors. Still on vector analysis. Now, if I have a vector arrow that is equal to axi plus ayj plus azk, the unit tangent vector t, which is actually a vector that is tangent to a curve at a particular point, and it has a magnitude of 1. The unit tangent vector t is equal to the arrow du divided by the modulus of the arrow du. So here we are saying that arrow is a function of u, and that means that a sub x is a function of u as well, ay is also a function of u, and az is a function of u. The unit tangent vector is the derivative of arrow with respect to u divided by the modulus of the derivative of arrow with respect to u. I said that the unit tangent vector is a vector that is tangent to a curve at a particular point, and the vector has a modulus or a magnitude of 1. Now, let us determine the unit tangent vector at the point for the curve with parametric equations: x equal to 3u, y equal to u squared plus 4, z equal to 2u squared plus 6. These are parametric equations of a curve. That's the curve we are considering in this case. Now, we have the vector arrow equal to a sub xi plus a sub yj plus a sub zk. What will be the vector equation of this curve that has these parametric equations? The vector equation of the curve is this. Arrow, actually it is a function of u. It's obvious. So arrow, which is a function of u, is equal to ax here will be equal to 3u, okay, times I. Ay will be equal to u squared plus 4, u squared plus 4 times j. Then az will be equal to this 2u squared plus 6, 2u squared plus 6 times k. So this is how to write the vector equation of the curve that has these parametric equations. Now, I can differentiate arrow with respect to u because arrow depends on u. So differentiate, remember how to differentiate a vector. I have a video for that already. That will be I, this is I, then differentiate 3u with respect to u plus j, then differentiate u squared plus 4 with respect to u, then plus k, then differentiate 2u squared plus 6 with respect to u. So the arrow du is equal to, differentiate 3u with respect to u, that's 3, times I, 3i, differentiate u squared plus 4 with respect to u, that will be 2u, times j, that's 2uj, okay, differentiate 2u squared plus 6 with respect to u, that will be 4u, alright. 6 is a constant, so the derivative is 0. The same thing with 4 is a constant. Derivative is also 0. So differentiate u squared. That will be 2 times 1, 2. Then subtract 1 from the power. That's 2u raised to power 1. Then differentiate 2u to the power of 2. That will be 4u. Because 2 times 2 is 4. Then subtract 1 from the power. That's 1. Times the k. So this is the arrow du, okay? Now, let's consider this point. This 3 is for x, this 5 is for y, and this 8 is for z. We are going to use any one of them to determine u. Now, this is what I'm saying. 3, 5, 8. We have the equations x equal to what? 3u. Okay, let me start with the first one. When I said x is 3 here, right? And y is 5, z is 8. So if I plug in 3 here, 3 is equal to 3u. What does this mean? It means that u is equal to 1. So this point corresponds to u equal to 1. What if I use y equal to u squared plus 4? Y equal to u squared plus 4. Y is 5. So 5 will be equal to u squared plus 4. 5 minus 4 is equal to u squared. This is 1 equal to u squared. So if I take the square root of both sides, it means that u is still equal to 1. What if I make use of the z equation, z equal to 2u squared plus 6? Z is 8. So 8 equal to 2u squared plus 6. 8 minus 6 is 2. If I divide both sides by 2, I'll be having 1 equal to u squared, which implies that u is equal to 1. So they are the same. So this point, 3, 5, 8, corresponds to u equal to 1. So I will say, at u equal to 1, dr du is equal to 3i, this is 3i, plus, I'll plug in 1 here. 2 times 1 is 2. 2j, plug in 1 here. 4 times 1 is 4, that's 4k. So this is the vector for dr du. What now is the modulus of dr du? Let's determine that. The absolute value of dr du, using the formula for magnitude of a vector that says that the modulus of a vector A is the square root of AS squared plus AY squared plus AZ squared. So I have the square root of 3 squared plus 2 squared plus 4 squared. 9 plus 4 plus 16. 9 plus 4 plus 16. 4 plus 16 is 20, and 20 plus 9 is 29. So the modulus of dr du is the square root of what? 29. So what now is the unit tangent vector t? The unit tangent vector t is equal to dr du, which is this, 3i plus 2j plus 4k, divided by the modulus of dr du, which is root 29. This is it. 1 upon root 29 into 3i plus 2j plus what? 4k. This is the unit tangent vector. This is it for unit tangent vectors. Keep supporting by subscribing to this channel, like and share the video to your friends and to your classmates.